Welcome back to part 4 of the Vex Isn't Scary project. This part, we're going over rendering and we're finishing up our project. Now you may think that there isn't much of a relationship between Vex and rendering, but there are a lot of things that you can do with Vex and your shaders, and that's what we're going to be doing in this part. Now, a quick disclaimer, I guess. I'm going to be doing this part in Mantra, so that you can follow along just with the basic version of Houdini, but the render that you see in the beginning was rendered with Redshift. However, you can very easily just do it in Mantra and you'll have the same, if not better looking results. Right, so from where we left off last, let's go ahead and add a few things to our scene. So we want this to be render ready. Let's go ahead and just add a basic camera to the front. We'll zero out the rotation on every axis, and we'll also zero out the X and Y values, just so that it's perfectly centered. Then we can adjust this translate. We'll do 6. Yeah, so 6 looks good. If you want a bit more space at the top and bottom, you can push that value up. We're also going to add a background to this. So let's go ahead and drop down a grid. This is going to be our background, so we can just call it background. Dive inside, and let's change this grid to be on the XY plane. We can then transform it back a bit, just until it barely touches the front face. So minus 0.15 seems about right for this one. We're going to increase the rows and columns to about 20 by 20, and that seems to give us a nice number of faces just around the circle. So we can now drop a blast node, and we're just going to blast a few of these faces. So go over to the group and select some faces. If you have edges or points selected, just switch to primitives, and you can now click and drag over this area. Press enter, and that'll just blast them away. We can then run a circle from edges, and we're only going to be selecting the inner edges. So switch to your group mode. This time we'll switch to edge select. Holding shift, you can click on single edges, or holding shift plus A, you can select edges along the same loop, just like that. Press enter, and it'll turn it into a circle. We can now do a poly extrude, and we're going to select this inner ring. So select a group. Once again, shift and A, we can select along the same loop. Once you have that selected, press enter, and we're just going to do a very small distance of about 0.05. We're then going to drop another poly extrude. We're going to select the new inside group. So we can do shift plus A, but now the cool thing is that this is actually a perfect edge loop. So if you hold shift A and then press middle mouse, it'll select the entire edge loop. Press enter, and we're just going to push it back a bit. But we're not going to use distance or inset. We're going to go down to transform extruded front, and we're not going to use local space because it's going to look quite broken if you try it. So for example, if you try adjusting your Z-axis, it'll push it down and to the left. It's using the object's local space. We want to use global space. So just switch this to global and then push it back on the Z-axis. So about minus 1.5, and that should be good. Then we're going to do a poly split, and we're not going to be using a path type of shortest distance, but rather an edge loop. Switch to your transform handle, and this will allow you to add an edge loop. So just click close to this edge, just like that. Now, what we've done here is we've added an edge loop on the inside and outside. And what that'll do is when we subdivide it, it'll keep some sharpness to this edge over here. So let's do a subdivide and just set this to a depth of 3. As you can see, this keeps some of the sharpness because we have those edge loops supporting them. And if you want, you can shrink down the entire thing or just shrink down the circle selection around it. I'm going to shrink down the entire grid just because we know what our camera looks like. So let's shrink this down a bit. And that looks pretty good to me. We can also just do some final adjustments to line them up. So maybe just a little bit forward as well. I think that looks pretty cool. So from there, we can just drop a null. And once again, the nulls, they're just to make things easy to reference. We can just call this background geo out. Cool. So now we have that. And that looks a lot like the render that I showed you. So now we can start adding the rest of the things. So let's begin on some material work. In our circle setup, what we would like to do is add an attribute that would allow us to track which circle is which. Now, there's a lot of use in that, because what you can do is you can randomize color based on that attribute, right? There's no identifier at the moment as for which circle is which. So if you wanted them to be different colors, it would be kind of difficult to do that. So a cool way to do it is to actually just add an ID attribute. So let's go ahead into our circle setup node. Once again, Alt+E, bring up your string editor. So under our axis calculation, we can also just add ID attrib. And what we're going to do here is we're just going to say set point attrib, and we're going to select geometry stream 0. The name of the attribute is going to be ID, both lowercase, and it's going to be for PT2. The value we're going to give it is going to be I. So the reason we're going to use I is because I is always going to be unique, right? We want a value for ID that's always going to be unique. There's only one line per I value and 1 point for that line. So I is a perfect value to use for ID in this case. So we can apply and accept. So now the cool thing is under our spheres blast, we can do something like an attribute randomize for color. So attribute randomize. And as you can see, that randomizes point colors. So over under options, we can just select a seed attribute. And in this case, the ID won't actually change anything. It's not entirely necessary, but it's good to have it. So you can go over to distribution now, and these are your values for your color. So it ranges from 0 to 1 for R, G, and B. So we can actually zero out R, we can zero out B. So now it's a random value for green, but we want it to be pretty much all green in our case. So we could do something like 0.8 and then add a bit of randomization on the other two. So 0.05 for red and 0.05 for blue, maybe even higher. And you can just play around until you end up with some values that you like. So as you can see, it gives you shades of green with slight variation. So that's cool. That's what I did for the final render, and it worked well. You could also do something a bit different if you'd like. So let's make a float spectrum. We'll just make float spectrum equal to I divided by lines, right? So this gives us a value between 0 and 1. We can set another point attribute, 0, comma, and we can just call this whatever we want, spectrum, comma, pt2, comma, and we'll just feed in that spectrum value. The cool thing with that is if we just bypass this attribute randomize and we just rather use an attribute wrangle, then we can do something kind of cool here by saying v at cd equals channel ramp, and we'll make this ramp a ramp called color or CLR, and it will be driven by at spectrum. And then we can create our spare parameters, go over to edit parameter interface, change this to a color ramp, apply and accept, and then set this to infrared. And the age-old problem of 0.0. So once again, we're dividing an integer by an integer. So all we have to do is just go back to this code quickly and put 1.0 times I divided by lines. I know it seems a bit silly, but we were dividing an integer by an integer, so there's no reason for it to be a float. So let's just put 1.0 times that value, and now our infrared will work. So now if you copy to points, you can see that it's a spectrum. And if you increase the number of points you have, right, it's a perfect spectrum. So that's a pretty cool thing that you can do if you want. So if you don't want to do the green one, you can maybe do the spectrum one. But I'm going to be doing the green one, so I'll just use my attribute randomize. So we know that these show up as green in our viewport. And the reason they show up as green is because Houdini recognizes the attribute CD. CD is the attribute that is used by the principled shader for the diffuse color. So if you have a CD attribute, by default, the principled shader will find it and use it for your color diffuse. But we don't want the actual geometry to be green. We want just the lights to be green. So I'll show you how to do that shortly. So let's just go and create a material network. So type matnet at the object level, and we can just call this materials. Inside here, let's create a principled shader. This one we will call sphere body. We can also create a principled shader called sphere light and another principled shader called base. So this will just be our base color. So let's go back to this Vex project and assign materials. So let's drop down a material node just over here. And this material node, we can select the group that we want to give a material to, and we can select light strip. Now we want to give light strip the material of sphere light. So expand materials and select sphere light. But what about the body? Well, we just have to click this plus. And over here, we can select light strip, but if we put an exclamation mark before light strip, that means not light strip. So then we can just choose the other material and choose sphere body. So now we're saying light strip has the material sphere light. And if it's not light strip, give it this material sphere body. And we can also go to the other side, drop another material node. This one over here, we don't need to put it to any group. We can just choose the material, and this is base. We can also jump up a level and go to our background, and our background will add a material here. We can call base for this one as well. So let's go set up our materials. For our sphere body, we just want a basic black shader. So let's go to our settings over here, and we can just choose black rubber, right? These settings are decent. It's a high roughness. It's a dark material. And if we go to render view and render it out, and you'll now notice that they're a darker color. However, they are still tinted green. And to stop that, all we have to do is disable use point color. On the principled shader, use point color. Once we've disabled that, they will no longer pick up that color. The next thing that we can do is go over to our sphere light. Now our sphere light, you'll notice it has a base color of this gray. We can just change this to white, right? So you'll notice that that already brings up the brightness of these rings, but we actually want there to be emission, light, right? We wanted to have some actual brightness to it. So if we scroll down to the bottom over here, you'll see we have emission color and emission intensity. Now by default, emission intensity is 1. If we change the color from black, you'll notice that it starts to emit light, right? So it's a white light at the moment. If we change it to red, you'll see it's that orangey light, but we don't want those colors. What we want is the color of our sphere. Now, diffuse uses our CD value, but what happens if we want CD to be used somewhere else? What we can do is use a bind node, and on this bind node, type CD, and all we have to do is change this type to a color, and then you plug CD into the emit color. And now you can see that all of those have changed to this green color. Right, it's now emitting a green light. And you can do this with any attribute. It doesn't have to be this CD attribute. You can bring any attribute into a shader. And that's another reason why Vex is so powerful. You can create attributes and bring them in here. For example, that spectrum attribute that we had earlier, we could use that in a ramp even. So let's say we were to bind in that spectrum value. So spectrum, we could then feed it into something like a ramp over here. So let's put a ramp parameter. Spectrum into the ramp, and then you could do maybe ramp into the emit color. And then over here we can choose perhaps an infrared, and there you have it, you have the different colors. And so as you can see, you can bring in whatever custom attributes you want into your shaders. So we'll go back to using our CD, and we'll continue with the rest of this. So our base will also just use that black rubber. So go over here to the cog and select black rubber. Jump up a level, and background isn't showing up correctly, and it's because I misplaced my display flag. So just switch it to that over there, and we can work on some lights. So let's just move to above over here, and we can add an area light by holding Control and clicking on area light. Back into render view, and it's starting to look a lot better. Now, we could also change this light to a spotlight, and I think I'll do that. So go down on the light to the spotlight options, enable spotlight, decrease the cone angle slightly, decrease the delta, and slightly increase the roll off. And then we can just adjust this area light's position. To something like that, so something a bit more dramatic. And then we can also just add a bit of a full light in the front. So switching off this lock, let's just add a soft light hitting the front. So just an area light, and we'll drop this exposure to about 0.3. And we can just change the color of the light that's above to a bit more of a blue tint. And our background and base are looking a bit flat, so we can actually improve this. Let's go over to our base, and we're going to add a couple of things to it. Let's add a turb noise, and we'll plug this turb noise into a ramp. So noise into the ramp, and this ramp is going to go into our roughness. Now, this turb noise needs a position to run off, so you can actually call for the global attribute. So global variables, just like this. And that will allow you to put in the position value. So it'll get the position from world space, and use that to drive your noise. If you check this out, it's going to be a bit of a mess. And so our roughness is a bit all over the place. Let's increase the frequency on this. A value of 4 looks decent. So as you can see, there's areas where the roughness is a bit lower and areas where it's a bit higher. We can increase the roughness on that so that our noise has a bit more detail to it. And then you can go ahead and change the ramp. So we don't want a roughness of 0 in any area. So just change this complete black to a gray. And you can choose a gray like that. It adds some patchiness to the background. And the other thing that will help this out a lot would be a bump. Drop a bump noise. And this bump noise requires the position. So plug in the global position. And then your displaced N value can go into your base N value. And you'll notice that there's what looks to be a bumpiness on the background. Now you can increase this frequency. I went for the look of plastic. So that very fine bump that you find on plastic. And to get that, you can use a frequency of about 100 and then just drop the bump height to about 0.002. So quite low. And what that gives you is a very subtle bumpiness. And you can make changes to this. You can slightly decrease the high end of the roughness. So just choose a white value on your ramp and you can decrease this. And we can make other changes like over here. So we can decrease how much this is inset. So let's do 0.02 for the multiplier. And that looks pretty good to me. The only other thing that you might want to add is a trail node on the spheres. So just over here, you can drop a trail node. And instead of preserving original, you can use compute velocity. What that will do is it will generate velocity as these move. As you can see, they have velocity. The cool thing about that is you can use it for motion blur. So if you go over to your spheres object over here and just go over to sampling, you can enable velocity blur. And then in your mantra IPR, you would also allow motion blur over here. Then when you want to output your image, you can just select a place to save it to. And in here, you can just call it something like vex project render $f.exr. So this will save out a sequence of EXR images, and then you can just say render to disk. And you can also change things like the resolution on your camera, and you can change focal length. You can add some depth of field. All of those things will help the look a bit. The reason I didn't include bump on these spheres is because they're moving. And when these objects are moving, you can't use the global P space for your noise because these generate noise based on the position in space. So if your object is moving through space, it will adjust the noise as it moves. So the noise will move on your spheres, and that doesn't look right. So to avoid that, you would add either a rest attribute or UVs. So I can actually show you the rest attribute thing. It's kind of cool. All you have to do is just on your spheres, drop a rest position, and you can plug it in over here. So just plug it in on any static geometry. So right over here, they'll now have a rest attribute. You can see it over there. Rest is a 3 float. And what you can do with that is bind in your rest attribute and use it instead of this P attribute. So I'm actually going to just delete the sphere body, copy this over on this side, rename this base 1 to sphere body. So we'll just now be using the same thing. Use a bind node, bind in rest, and we saw that it's a 3 float or a vector. And then delete these global variables from here and just plug this into our position over here and over here. Now, if we take a look at the render, you'll notice that there's some bumpiness and there's also some motion blur. So the motion blur looks a bit hectic in here. You can adjust it however you see fit. So you can even reduce the velocity scale on the actual trail node to something like that. And now you can see that the spheres have the same material as the base. Finally, if you also want to add the light that rotates behind, you can do that as well. In your setup, you can actually just add an extra point outside of the rest of the code. So if we just bring this back up, all you have to do is say x equals sine of radians timescale and y equals cosine of radians of timescale. And then you feed that into a vector. So vector outer pt equals set x comma y comma 0. And then we can also int pt equals add point 0 comma outer pt, and then we can just set the point group for that point. So geometry stream 0, we can just call it outer, and we'll put this pt into it and set, apply and accept, And you'll notice that we have an extra point now if we blast everything else. So blast everything other than outer, delete non-selected. We have this point that just moves around the outside of the circle. So now if we just template our base, what we can do is do some transforms to this. So let's just transform it before we blast, transform it up a bit so that's on the edge of our base, and then move it back. And then what we can do with that is just copy 2 points. We can bring in that sphere that we have, drop a null, and just call this ring light. And then we can drop a geometry light, and the geo light, we can just go over here and choose the geometry object. The geometry object will be our ring light. And if we just adjust the color over here to a green and increase the exposure a bit, you'll begin to see that light over there on the edge. And all you have to do is make some minor adjustments. And also there's an extra sphere now. And over here, we can make a few minor adjustments to this sphere. Can bring it a bit forward, just like that. And increase the scale a bit more like that. And then we can also just put a light behind it. So just one big area light at the back. And this area light can also be green. And that extra sphere that's showing up in our render, all we have to do is just go over here. On our copy to points, we can actually just choose which points we want. We only want it to copy to spheres and not to our outer points. And that'll remove that. And so your final render should look something like this. And that little light over there will track around as this goes. So yeah, that's it. That is the end of the Vex Isn't Scary project and the Vex Isn't Scary series. So thank you for following along with me. I hope that you had fun. I hope that you learned a whole bunch about Vex and all the things that are possible with it. We went from complete basics to making a full setup completely out of Vex. So if you enjoyed the series, leave a comment, let us know what we could have done better, what we could have done differently. It's always good receiving some feedback from you guys. And also I'd love to see what you do with this effect. Feel free to change it up, completely remove the background maybe and add glass tubes instead of these indentations, or use cubes instead of spheres, and maybe randomize the colors, do something cool with it, and tag us on Instagram. Our Instagram is at 9_between. So if you want to tag us there, that's at 9_between. And if I see it, I'll be sure to leave you a comment. So I really hope to see all of the awesome work that you guys put out. It was really cool with the Houdini Isn't Scary series, so I'd love to see what you come up with for the Vex Isn't Scary series. And yeah, that brings us to the end. So thank you for following along. I hope to see you very soon with more of our content. And so until then, bye.